the 6 concepts and exercises. Okay, we go now here. We click. We open the PowerPoint, and we also opened the exercises. Okay, now on this concept, chapter 6 is about capacity planning. Okay, capacity is important for organizations. It is the most difficult subject of organization. It has long-lasting effect. Some capacity decisions take more than 10 years to take an effect. Making decisions regarding capacity is important. Why? Because if you make wrong decision under capacity situation, can mean losing profit or unsatisfied customer. Higher capacity can also mean you have too much capacity, which is doing nothing, and the company must invest into that capacity instead of using the money to do something else. So making decisions regarding capacity is always a trade-off between not too much and not too little. Okay. In this chapter, the capacity means the maximum rate of output of a process or a service. Example of capacity can be the maximum boxes that the process can produce a product, or how fast the process can run. How many hamburgers one employee can make in 1 hour. That's how we define capacity. Capacity decision is very crucial for long-term success and growth of organization. Many areas in organization must make decisions regarding capacity in their own ways. Capacity planning can be done in 2 specific timing. The first one we call long-term capacity planning. Long-term capacity plans deal with investment in a new facility, equipment at organizational level, and require top management participation and approval. Normally, long-term capacity planning may take longer than at least 2 years into the future. And we consider long-term capacity planning as capital intensive, meaning long-term capacity planning take too much investment of organization. On the other hand, short-term or operational level capacity planning can be used to solve short-term problem in organization. Okay. Short-term capacity planning may include hire additional workforce, using overtime to deal with inventory problem, or have a safety stock or buffer for an extra inventory. Mostly, short-term capacity planning is dealt by operational or middle management people. This picture shows difference between the long-term capacity planning and short-term capacity planning in terms of the issue that will be discussed. Regarding long-term capacity planning, the issue regarding something in the big picture, like example, economies and this economy of scale, the timing and sizing of the capacity, or the systematic approach to make decisions regarding capacity. For short-term capacity planning may deal with the theory of constraint, the identification of management of the identification and management of bottlenecks, product mix, and also managing constraint in the line process. Okay, dealing with short-term capacity planning, the concept of theory of constraint can be applied. Theory of constraint, or TOC, okay, will be discussed more in chapter 7, which will not be covered in this class. Theory of constraint, or TOC, is a systematic approach that focuses on actively managing constraints that are impeding progress toward its goal of maximizing total value added, sell less discount, and variable cost. Theory of constraint was developed by Eli Goldratt. What is constraint really? Constraint is any factor that limits system performance and restricts its output. If we say capacity is the maximum rate of output, then the constraint is something that impedes organization to achieve capacity. Constraint in organization can be many things, but the main thing of constraint is a bottleneck. Bottleneck is an output constraint that limits a company's ability to meet market demand. Sometimes we also call a bottleneck can be called capacity constraint resources, or CCR. Constraint is any factor that limits the performance of a system or restricts its output. When constraint limit excess, capacity can be imbalanced. Constraint can occur up and down the supply chain, can be either in the supply chain side, the supplier side, or in the customer side, or within the firm processes. It can be physical, like machine, labor, or workstation. Can be managerial problem like policy, metrics, or mindset. This picture shows the representations of bottleneck. The first situation, there are three processes that interconnected. Process number 2 is considered a bottleneck because the process has output maximum of 50 per hour, which impedes the maximum output of the whole process. Okay, with that in mind, if we find out that process number 2 creates bottleneck, we must identify the problem and get rid of the problem by adding additional capacity to it. So the maximum output can be 200 per hour in this case. How can we measure capacity? Capacity can be measured by two ways. The first is to measure by the output measures. The output measure can be number of units produced per day or the output rate. Output measure is suitable or appropriate in a situation where the organization has high volume and less flexible process, meaning that the output may be only a few, but the output has high volume. The firm with small number of output of product and services can use output measure as a measurement for capacity. Example of this type of measurement can be ABC Bank offer only two options, online or normal bank. The second output measure, the second measure of capacity is input measure. Input measure is a situation when organization use and input resources to measure the outcome, the capacity, such as the amount of meat used in a restaurant or the amount of electricity used at the factory. Input measure is appropriate when organization has low volume but very flexible outcome, like such as in the high-end restaurant situation. Okay, how to measure capacity? Okay, capacity is the maximum output or maximum you can do. Normally, organization will not run organization at maximum. The average the organization can run, we call utilization. If organization use output measure for capacity, utilization can be measured by average output rate divided by maximum capacity. For an input measure capacity, utilization equal average hour worked divided by hours available. Percent efficiency equivalent to standard hours produced divided by actual hours work. Okay, this show you an example of the utilization measurement. In this example is Dahlia Medical Center. This center is responsible for delivering baby. Okay, so in this situation, okay, happened in 3 facility that we are interested. One facility we call labor room. Second facility we call labor and delivery rooms. And the last facility we call delivery room. Okay, so in this example, okay, we're gonna go to exercise number 1. In this exercise, okay, we are going to use the area in the blank area to complete the exercise. Okay, we are interested in 3 facilities to identify utilization. Okay, as you know, this type of facility does not have high volume but have high or flexible outcome. Thus, the input measure is suitable. The input measure that we are going to use for this example is hours of operation. Okay, so we use an input measure of capacity, and then we can use hour. Okay, first facility we're gonna call it labor room. Second facility we're gonna call labor and delivery room. And last facility we're gonna use called delivery room. Okay, now percent utilization, just to remind everyone, percent utilization. In this case, we use input measure. We're gonna use average hour work divided by hours available. Okay, so in this organization, we are interested in 3 working day period for each facility. Okay, and each facility may have many rooms. For example, labor room, you have 30 labor room. Okay, so for this labor hour available equivalent to 3 days, and each day maximum of 24 hours all day, and you have 30 rooms, so hour available is about 2060. Okay, for actual hour or hour usage, okay, in this facility 60 baby were born on the labor room, and on average time spent in labor room is about a day. Okay, so you have 60 baby, each baby spend about a day or 24 hours, so our actual use is about 1440 hours. So I hope student is working along with me. Okay, so percent util or in charge of utilization equal 1440 divided by 2060 times 100 to make it percent, which is equivalent to 66.67% utilization. Okay, so moving on to next facility. On next facility, we do the same things. First, we find out hour available. Okay, the labor and delivery combination, you have about 15 combination room. Okay, so we have 3 days, each 24 and 15 room. Okay, and then actual hour equivalent to, okay, you have 45 baby were born on a combination. Okay, each baby also take about an hour, maximum an hour, maximum a day or 24 hours. percent util equal or 100%. Okay, as you can see that percent utilization cannot be beyond 100% because capacity is the denominator is or cannot be beyond the maximum output. Okay, for the delivery room you have hour available of delivery room. You have 3 delivery room. Okay, each room 3 days and 24 hours, which will take about 16 hours available, and then actual hour equal, you have about about 60 baby will also be delivered, and each delivery room take about 1 hour. Okay, so percent util equal 60 divided by 216 times 100, or about 27.78%. Okay, the question asks, which of the facility had the greatest utilization? You can see that labor and delivery room has the greatest percent utilization. Okay, now let's go back to the slide. So we finish example of utilization, and also the book has a few examples that you can follow. Okay, please review it. Okay, next concept discusses about the capacity and scale. In this section we will discuss about economies and this economy of scale, which is the issue regarding long-term capacity planning. Okay, so economy of scale. Economy of scale, okay, is a situation, okay, that can explain the states in organization at which the average unit cost of a service or goods can be reduced by increasing its output rate. Okay, economy of scale is a situation, okay, when you increase the volume or the demand of the output. In this situation, for example, is a hospital. The hospital may start out organization with 250 bed hospital. One hospital increased its capacity more and more and more. Okay, when the output rate increased, the average unit cost may decrease. Why it is decreased? Because the number of the output, in this case patient, is increasing, drive down the average cost. Okay, the cost that go down may come from fixed cost, or the cost of construction, or the cost of facility, or the cost of the machine. It can be also the cost of material that purchased, and the cost also come from the learning curve. When the organization increase their output, they are learning and they are taking advantage of the knowledge that they learn. They do things better. Okay, so when organization increase volume and the average cost go down, this area we call economy of scale. On the other hand, the opposite side of economy of scale we call diseconomy of scale. This economy of scale occurs when the average cost per unit increases as the facility size increases. Okay, this economy, as you can see from this figure, as the volume of output increased from 500 to 750, the average cost start to go up. Why? Because the organization tend to be more complex. The organization loses focus. The process become inefficient. The organization become too stout to be efficient. Okay, so this area, when you increase the output and the average cost go up, we call this economy of scale. Okay, so these are the summary of it. The size of capacity. When making decision regarding the long-term capacity, organization may not make decision lightly. Why? Because too much capacity can also be wasteful of money, and decision regarding capacity is very capital intensive. When making decision regarding capacity, organization may also use another term to measure the capacity. We call capacity cushion. Capacity cushion is 100% minus average utilization rate. Okay, now let's look at example. A capacity cushion is the amount of reserve capacity that a process has to handle a sudden increase in demand or temporary losses of production capacity. Capacity cushion is an inverse of percent utilization. Is consider capacity level for just in case situation. In an operation, the example of capacity cushion can be safety stock, or in the service organization, capacity cushion can be extra people just in case for the volume to go up. Okay, this example number 2 discusses about the relationship between percent utilization and capacity cushion. Okay, so in this example, the current situation has an average of 50 customers per day. An observation shows that 50 customers per day is considered 90% utilization. Okay. So as you can see that percent utilization on the current situation, percent utilization equal 90% or equivalent to 50 customer per day. Okay, percent cushion is an inverse of utilization. So the current percent cushion equal 100% minus 90% or about 10%. Okay, percent cushion, sometimes we use term C to denote percent cushion. Okay, so capacity equal average customer divided by 1 minus C divided by 100. 1 minus cushion divided by 100. So in this case, the current capacity is 50 divided by 1 minus, let's put parentheses, 1 minus 10 divided by 100 or equal 50 divided by percent utilization, which is about 0.9. Okay, so in this particular example, you can see that the current capacity is about okay, 55.5 customers. Okay, so now next is the five-year. In the next 5 years, okay, in the next 5 years, say that if the demand is expected to be 75 the current, so the average customer number will change to about 0.75 of the current 50, or about maybe 37.5 customer. Okay, and then this is considered equivalent to 5% cushion, or 95% utilization. Okay, so question asks, what is the capacity requirement? Okay, now let me fix the top also. Let's put note requirement in there. So, okay, capacity requirement now equal average customer divided by 1 minus Kuchan divided by 100. Okay, which equal 37.5 divided by 1 minus Kuchan now is 5, or about 37.5 divided by 0.95 utilization, 0.95. Okay, which equivalent to about 52.63 customer. Okay, as you can see that the number of capacity go down significantly. Okay, so that is example regarding the relationship between Kuchan and percent utilization. Okay, next concept we will study about why do we need Kuchan, and what situation requires large Kuchan and what situation requires small Kuchan. Okay, as you can see, Kuchan is referred to an extra capacity for just in case situation. Small capacity is preferred in a situation when the organization has high capital intensive investment. Okay, such organization can be manufacturing in general, airline industry in a service, or cruise ship in a service. Okay, in this type of organization, when you have large capital investment, small Kuchan is preferable because small extra capacity can mean extra money that to investment, just in case that in this type of organization the small capacity can mean a significant amount of money, which the intention is to be idle or to make no profit, to not use effectively. So it is very it is suggested that small Kuchan is preferable in high capital intensive environment. In labor intensive environment, on the other hand, prefers large Kuchan. Example of labor intensive environment can be like a retail store or a service store in general. Okay, in situations that require large Kuchan can be when customer expect fast delivery times, like a retail store, when demand varies very much, when future demand is uncertain, when customer change products mix regularly, when there are uncertainties in the supply, like for example employee absenteeism, vacations or holidays period. Okay. The advantages of have a large Kuchan can be large Kuchan sometimes appropriate when demand varies, such as in the service industry, when future demand is uncertain, when there is new products offering, when supply is uncertain, such as level of workforce, vacation period, or rare raw material. The disadvantages of cushion can be the capacity can be unused and wasteful money. High cushion can show inefficient way of managing the process. Next concept is the size and capacity expansion. There are two strategies, at least three strategies for capacity expansion. First, capacity expansion we call expansionist approach. Okay, expansionist approach represent the type of expansion that always preempt the expansion of the other firms. This type of expansion organization always look ahead and trying to have higher capacity than the capacity required. This type of expansion may happen only once in a while or a few times. Okay, and the length or the timing between expansion can be quite a long term. Okay. This type of expansions can result in economies of scale and a faster rate of learning, thus helping a firm reduces its cost and compete on price. These strategies might increase the firm market share or act as a form of preemptive marketing. Next type of expansion we call wait and see. Okay, wait and see strategy is to expand in a smaller increments, such as by renovating existing facilities rather than building a new ones. Because the wait and see strategy follows demand, it reduces the risk of over expansion based on overly optimistic demand forecast. However, this strategy has its own risks, such as being preempted by competitors or being unable to respond if demand is unexpected to ignite. This type of capacity always lose the benefit because it's always under the capacity requirement. This type of capacity requirement happened very often, but each period of capacity expansion is considered a short-term approach. Okay, next we will discuss about capacity requirement. Capacity requirement can be used both input measure and output measure. A capacity requirement can be measured by the formula. This formula, it depends largely on how many product or service that offer. If organization offer only one product or one service, the capacity requirement, or M, represent number of machine or man hour, equal D times P divided by N times 1 minus cushion divided by 100. And you can see that the 1 minus cushion divided by 100 is something that we experienced before. Okay, D represent annual demand, P represent processing time, N represent the hour available, C represent cushion. when organization offer more than one product and services, this formula can be used. As you can see that the bottom part stay the same. The top part, on the other hand, okay, has a setup time part to add to it. So instead of having only D time P represent processing time alone, the top part may add the setup time D divided by Q time S to add to it, because between two products, organization must wait and getting the process ready for the next product, and that time we call setup time. Okay, now let's look at this example. This example, organization, okay, has two product to offer. One product is offered to client X, another product offered to client Y. Each product may have different demand, processing time, lot size, and also the setup time. Okay, so these are the formula we use. We will put unit into the right area. Bottom part represents total hour available, which is 250 days per year. 1 shift per day, 8 hours per shift. With organization have 15 cushion. Okay, as you can see, organization need about 3.12 machine. Always adjust upward. So at least 4 machine has to be bought. Okay, so we can experiment this on example number 3. Okay, on example number 3, there are 3 products in this organization. Men's sandal, women's sandal, and children's sandal. Okay, and each product have different processing time, setup time, lot size, queue, and also demand. Okay, so we are going to use first machine equal. Okay, we take the top part, which is D time P. D mean demand, P mean processing time, so 80,000 time P okay, plus D divided by Q lot size. Okay, and that's considered men for men product. Okay. Plus second part, which is the one with the women. Okay, 60,000 processing time 0.1 plus 60,000 divided by 180 times setup time 2.2. Okay, as I look at this, I realize that I forgot the first part. I forgot to add the last piece, which is the setup time 0.5 on the men. Okay, last part we're gonna add is for children. The children part is 120,000 times 0.02 plus 120,000 divided by DOQ 360 times 3.8, that will be children. Okay, and all together with this, we're gonna maybe, let's see if I can draw some line. Like that. Okay, the bottom part will represent the hour available, and which is we have about 50 weeks per year, 5 days a week, so we have 5 days a week, 50 weeks per year. Okay, and we have each day you have 2 hours, 2 shifts, each shift 8 hours. Okay, all together, 1 minus cushion, we have 5% cushion divided by 100. Okay, now let me calculate it using my calculator a little bit. Okay, based on my work, it's about 3.8 machine, or we gonna adjust upward to 4 machine. Okay, so the question is that how many machine needed? We need 4 machines. B said if the operations currently has 2 machines, what the capacity gap? So part B, capacity gap equal, okay, if you have 4 machines, you have 2, so capacity gap about 2 machines. Okay, which means you have to, if you want to invest additional, you must invest 2 more machines. Okay, and you guys have another example 4 to work on, and the answer is over here. So I hope you trying to work on it, and then make sure you compare with the result. Okay, now go back to the slide. So we learned about cushion, and I think that pretty much at the end of this chapter. Okay, I hope you practice on question number 4. Thank you so much.